Hi guys, we need to come up with an idea since deadline is approaching.
I know, but our minds are totally stuck.
We've tried our best, but we really can't think of any.
Hey, see, there's lightning!
What? I'm so afraid.
Are you still a little kiddo?
There's no reason for you to be frightened. Just simply remember that every time you encounter a lightning, just cover your ear and prepare for the coming loud sound of thunder.
Oh, I see. But why is there a delay? Why does such a phenomenon happen?
To be honest, I don't know either.
What? MK not? I finally come up with some idea. We can use the speed of sound in air as our topic.
Great idea! With the help from AIs, we can just do it fine.
Cool. Let us write down our question.
Ta-da! We received orders from Master Kevin and we are here to serve you!
So let's come and do an experiment to solve your curiosity.
Stand 35 meters away from a large blank wall. Bang two pieces of wood together. Listen for the echo. Ask another student to time a clap. During this time, the sound has traveled 70 meters to the wall and back. Repeat for 10 times. Divide the distance by the time to work out the speed of sound. Calculate the average speed of sound.
Cool. We managed to find out the speed of sound in such an easy way. Thank you, guys.
You're welcome. See you next time. Bye-bye.
Hey, when can we leave school? I'm so tired after days of lesson.
Stop complaining. We are all tired, but we have to finish the project as soon as possible. Deadline is approaching.
Hey guys, do you hear a strange sound?
But where did the sound come from?
I heard that there's a ghost in this floor.
Hey, stop! Don't scare us. Maybe it's someone playing an instrument.
Why don't we look and find where does the sound come from?
Sure!
Hey, there's a guy inside. Let's take a look. Master Kevin and the AIs. Hey, why are you here?
Nothing special. I'm just testing the tuning fork and preparing the experiment for the lesson. So when you're here, come and help me out.
Connect the millisecond timer with the two microphone units. Place the two microphone units 50 cm apart from each other. Bend the metal rods to create a sound. Record the reading on the timer. Repeat using the same distance between two units. Move one of the microphone unit further from another unit. Repeat the process again. Record the time that has varied. Work out the speed of sound using the formula V equals to F lambda for each of the results taken.
Wow, this experiment is amazing. We can use this to do our assignment. Thanks, Master Kevin.
Miss, here's our assignment.
Okay, let's see. Well, you girls did a good job. These two experiments are typical ways to find out the speed of sound, but I think there is a more precise way. But before I tell you the answer, I think it is better for you to discuss among yourselves.
This says there are more accurate methods to find the speed of sound, but how?
I'm also wondering. I totally have no idea.
Maybe there is something really powerful on Earth, like a super machine that can measure the speed of sound.
What is
on finding the speed of sound. Isn't this topic of our assignment?
Let me see. Here are the procedure. Maybe we can follow this and carry an experiment that is more accurate.
Then what are we waiting for? Let's start!
Connect the resonance tube with the sound wave generator. Then connect the microphone with the oscilloscope. Place the microphone near the loudspeaker as shown. Switch on the sound generator to create different frequencies of sound. Observe the waveform on the oscilloscope. Slowly pull out the piston until the loudest sound is heard and the same waveform is formed. Record the distance moved by the piston. Calculate the wavelength by multiplying the distance by 4. Continue to pull the piston until another larger sound is heard and the same waveform is seen. Calculate the wavelength again by multiplying the distance by 3. Work out the speed of sound by formula V equals to F lambda for each of the results taken.
So ladies, what have you learned in this assignment? We have done 3 different experiments to find out the speed of sound in air.
Although the first experiment is the simplest, it's the most unreliable one because our ears are not as sensible as machines, which can detect sound very accurately.
As we cannot control and reduce our reaction time, the time needed for us to press the stopwatch is not always the same.
Also, since the corridor is not an open area and not in an absolute silence, we can't hear the echo clearly. As a result, there is a big difference between the speed of sound we calculated and the actual speed of sound in air.
On the other hand, the second experiment provides a more reliable result. However, there is some error that we have to avoid.
For example, getting an accurate distance between the 2 microphone units can be tricky because the meter rule is not as precise as what we think, and we may see different readings from its field from different angles.
Also, the microphone units can be distracted by the other sound like the fan and also the noise outside the lab.
Meanwhile, the last experiment is the most precise among all the experiments. We did not only hear the sound by our ears, we also used the oscilloscope, which visualized the data. This gives us a more accurate result.
However, every experiment has errors, such as random errors or systematic error. Sound waves can be affected by the environment. If the surrounding is noisy or windy, sound cannot be heard easily. Moreover, temperature and humidity affect the speed of the sound.
You are right, higher the temperature, faster the sound travels, and if the humidity increases, the speed of sound also increases.
Besides this systematic error, there is also other errors such as reading the scale on the ruler or measuring cylinder incorrectly.
Every experiment has errors, but we can't totally avoid them. What we can do is to be more extra careful while doing the experiment and repeat it to find a more reliable result.
Oh, you really learned a lot in this assignment. To conclude the lesson, let me tell you the actual speed of sound in air. It's around 343 meters per second. But you know what? Sound travels even faster in liquid and solid because the particles in liquid and solid are closer to each other. So sound energy can be transferred by particles in a faster rate. Okay, this is the end of our lesson. You may leave.
Ta-da! This is it! Order from Master Captain and Reaction!
Hey!
I can calculate the speed of sound.
Bye-bye.
Last one.
When is viewed from different
Energy can transfer by
Nothing special. I'm just testing the tuning fork and preparing the next.